Hi friends, welcome back to Wisdom Academy YouTube channel. In the previous class, we learnt about principle of superposition. I solved a few numericals for you and today we are going to see electric field. Before I start talking about electric field, I remember I gave you a homework. I asked you to find the relationship between the electrostatic force and the gravitational force. I gave you some hints also, and those who have done in the home, they would have got to know that electrostatic force, being one of the very strong force, is approximately, I will say, 10 to the power 39 times of gravitational force if you would have considered one proton and one electron, or if you have taken proton it will be 10 to the power 36 times and so on. But see that electrostatic force is 10 to the power 39 times of gravitational force. That is its intensity, is very strong force, right? Coming back to electric field. Now electric field, what is electric field? You should think about it, because when this electric field comes, you can relate it to magnetic field. So suppose there is a magnet, it will have a field around it. Same way, there is a charge, it will have a field around it. So how we talk about magnetic field? It is the area around the magnet in which its effect can be felt. Same way, electric field is something like area around a charge in which its effect can be felt. Now suppose there are two charges, they may have electrostatic force of attraction or repulsion, but they are not in direct contact. So how this force is acting? It acts by its field. I hope you are understanding what I am trying to say. There are two charges and these two charges are getting attracted or repelled by some force. Though they are not in direct contact, they are being acted upon by a force. This force is coming because of the field present around these charges. Now, if you want to find the magnetic field around a magnet, what you do? You take a magnet and you keep for checking it. Am I right? So when there is a magnet and I want to check around it how much far the magnetic field is there, you bring another magnet or any other magnetic material and check it. Same way, if there is a charge q, suppose plus q or minus q, I want to check its field, I need to bring a test charge. We call it as test charge. By convention, generally we take positive test charge. This is called as unit positive test charge. Unit positive test charge. This unit positive test charge will help us in finding what is the electric field around this charge. So this unit positive test charge will help us to identify what is the electric field around it. So electric field can be defined as the force experienced by unit positive test charge. Mathematically we write electric field as force per unit test charge. This is the mathematical value of electric field. And what is the SI unit of force? It is Newton. What is the SI unit of charge? It is Coulomb. So SI unit of electric field would be Newton per Coulomb. Right? Now, from this formula, we come to know that F is equal to QE. This is the relationship between force and electric field, and remember that this will be very useful for you. This will help in solving lot of numericals. It will also come when you learn about the other concepts like Lorentz force or cyclotron. So remember that this formula is very important, and how it comes from this thing. So force is charge times of electric field. Now let us see one question based upon electric field. A particle of mass 10 to the power minus 3 kg and charge 5 microcoulomb is thrown at a speed of 20 meter per second against uniform electric field of strength 2 into the power 5 Newton per coulomb. How much distance will it travel before coming to the rest momentarily? Now in this question, what you should be noting, first the mass of the particle is 10 to the power minus 3 kg. And what is the charge on the particle? 5 microcoulomb. It is thrown with a speed of 20 meter per second and it is going against a uniform electric field. Very important point, because when it is going against uniform electric field, definitely it will deaccelerate. Remember this. And they have given the strength of the electric field is 2 into the power 5 Newton per coulomb. They are asking you to find how much distance it will travel before coming to rest. So This question involves knowledge of electric field, and I think at the end you must use some mechanics before ending this question. Right. So, mass is 10 to the power minus 3 kg. Q is 5 into 10 to the power minus 6 coulomb. I hope you know that 1 microcoulomb is 10 to the power minus 6 coulomb. And they have given the electric field as 2 into 10 to the power 5 Newton per coulomb. It is its magnitude. Okay. Now we can find from here. See, Q is known to me, E is known to me. I can find the force on the charge because just now I told you F is equal to Q E. So what is Q? 5 into 10 to the power minus 6. What is it? 2 into 10 to the power 5. So when I multiply, it will become 10. So how much it will come? It will come 1 Newton. Because everything is cancelled. I will get the force as 1 Newton. Now force is known to me, mass is known to me. I can find acceleration. By Newton's second law of motion, we know that F is equal to mass into acceleration. Here I am using minus A. Why I am using minus A? Because I know it is deaccelerating. So what A will be? A will be minus F by M. What is the force? 1 Newton. What is the mass? Mass is 10 to the power minus 3 kg. So what I get? I get 10 to the power 3 meter per second square as the acceleration of the particle. So now I am knowing acceleration is 10 to the power 3 meter per second square. I am knowing force is 1 Newton. I will try to find what is the value of distance. So equations of motion. What is the third equation of motion? V square is equal to U square plus 2AS. So since the particle will come to rest at the end, I can say that V is equal to 0. And what is U? U is given as 20 meter per second. They have given the value of U as 20 meter per second. I will put that value here. So 20 square plus 2, A is 10 to the power 3. Yeah, I think here minus I have missed. Minus will come here. So minus 10 to the power 3 and S. S is want to be find. So when I solve this, it will become 20 square is equal to 2 into 10 to the power 3 into S. So what will be S? S will be equal to 20 into 20 by 2 into 10 to the power 3. So 2 gets cancelled, 0 0, it will become 10. So S will be equal to 0.2 meter. So distance it will travel before coming to rest will be 0.2 meter. Now we will see electric field due to a point charge. So there is a point charge, let me name it as Q. I need to find what is the electric field due to this point charge. Just now I told you, if you want to find electric field, you must keep a unit positive test charge. So at some distance I am keeping a unit positive test charge. Let the distance between them be R. R vector I am writing. So if I assume the charge Q to be positive charge, definitely Q naught will be repelled by some force, right? So what will be that force? That force will be, by Coulomb's law, it will be K Q naught by R square R cap. I hope you remember the Coulomb's law in vector form. Now just now we have seen E, electric field, is equal to force per unit test charge. So let me put it here. Electric field will be equal to force K Q naught by R square. Again Q naught will come, R cap is there. These two gets cancelled. I get the value of electric field as K Q by R square R cap. This is the vector representation of electric field for a point charge. So what is the magnitude of electric field due to a point charge? It is K Q by R square. So magnitude of electric field due to a point charge is K Q by R square. Vector form is K Q by R square into R cap. Electric field due to system of charges. So this thing is very similar to principle of superposition, what I told you in the previous class. So previous lecture was based upon principle of superposition, where I told you there are more than 2 charges present, how to find the force on that. And what we came to know, the net force acting on one charge is the vector sum of all the individual forces between two charges. Same way here, if there are more than two charges and you want to find the electric field to the system of charge, same by using the principle of superposition, the net electric field will be the vector sum of all the individual electric fields. So if you have more than two charges or one charges and you want to find the net electric field due to the system of all these charges, then that will be equal to vector sum. Remember the word vector sum of all the individual electric fields. Right? One more thing you should remember is that the direction of electric field is always, since F is equal to QE, direction of electric field will be always same as the direction of the force, or vice versa. Direction of force on a charge is always equal to direction of the electric field. They both will be similar. Let us see one question. 2-point charges of plus 5 10 to the power minus 19 coulomb and plus 20 10 to the power minus 19 coulomb are separated by a distance of 2 meter. Find a point on the line joining them at which electric field intensity is 0. Electric field intensity, electric field strength, all are same thing. So there are two charges given. One charge is plus 5 into 10 to the power minus 19 coulomb, and second charge is plus 20 into 10 to the power minus 19 coulomb. They are separated by a distance of 2 meters. They are asking you to find a point. Let this be Q1, let this be Q2. They are asking you to find a point anywhere in between two charges where the net electric field is 0. So I said you, whenever you want to find electric field at any point, you must keep a unit positive test charge. Let that be Q0. So when I keep a unit positive test charge, the electric field direction of Q1 will be repelling, because positive will repel each other. Same way, the electric field direction by Q2 will be repelling, because that is also positive charge. So if I write it as E1, this would be E2. So now, at this point, the electric field to be 0, definitely E1 must be equal to E2. So as per this question, the condition given is E1 is equal to E2. So what is electric field magnitude? KQ by R square, right? So KQ, Q1 I will write KQ1 by R. So if everything is 2, let me take this as X, right? So what will be this remaining distance? The remaining distance will become 2 minus X, isn't it? So if suppose the distance from Q1 to this point is X and total distance is 2, so remaining distance will become 2 minus X. So KQ1 by X square will be equal to KQ2 by remaining distance 2 minus X the whole square. Yeah, I can write like this. So K gets cancelled. What is the value of Q1? 5 into 10 to the power minus 19 by X square is equal to what is Q2? 20 into 10 to the power minus 19 by 2 minus X the whole square. So what will happen? This will get cancelled. This will become 4 times. So I get the equation as 2 minus X the whole square is equal to 4X square. The square I move it that side, I get 2 minus X is equal to plus or minus 2X. Isn't it? When I solve this equation, I will get the value of X. I will get two values of X. One will be neglected if it is not suiting there. Another value may be taken. So it will be, if you take plus 2X into consideration, then you will get the value of X as 3 by 2. And if you take minus 2X into consideration, X will become equal to minus 2 meter. So in both the cases, if you see that when X is equal to minus 2 meter, then this becomes 4 meter. It is not possible. So this case definitely not possible. So X is equal to 3 by 2 meter is my answer. This is how we solve this question. And mind that this E1 is equal to E2 is only valid or only there when the case is given as Q1 and Q2 are positive. In the same question, if suppose plus 20 would have been minus 20, then will the diagram be like this? No, it won't be like this. Let me draw it once again for minus scenario, and let Q1 be plus 5 into 10 to the power minus 19 coulomb. Let Q2 be minus 20 into 10 to the power minus 19 coulomb, and distance let it be same 2 meter. And then they would have asked you to find the point at which the net electric field is 0. Then see, keeping a positive charge here, this will give a repelling force. Being negative charge here, positive here, it will also be a attractive force. So both the forces are the same direction. So in this case, if this is E1 and this is E2, then how will we write the net electric field to be 0? We will write like E1 plus E2 is equal to 0. And then we will solve the whole equation. So remember that this E1 is equal to E2 is not for all the cases. In this case, since both the charges given are positive, E1 is equal to E2 case came. If one charge would have been positive, one would have been negative, then E1 plus E2 is equal to 0 case would have come. Right? Let us see one more question. 2 point charges Q1 and Q2 of 10 to the power minus 8 coulomb and minus 10 to the power minus 8 coulomb are placed 0.1 meter apart. Calculate the electric field at point A, B and C. So there are two charges. Let me name it as Q1 and Q2. They have a value magnitude of plus 10 to the power minus 8 coulomb and minus 10 to the power minus 8 coulomb. They are placed 0.1 meter apart from each other. They are asking you to find the electric field at A, B and C. So they have given the positions of A, B and C. So we will do by one by one. Let us see for A first. So for A. Now if you see at A, this charge, I said you whenever you want to find the value of electric field, you must keep a unit positive test charge. So when I keep a unit positive test charge here, this positive charge will repel it in this direction. Let me name it as E1. At the same time, this negative charge will attract. So electric field will be E2 in the same direction. Am I right? So what will be the net electric field? It will be E1 plus E2. So E net will be E1 plus E2. So what is the value of E1? E1, that is the electric field produced by Q1 charge, that will be equal to K Q1 by R1 square, and E2 will be K Q2 by R2 square. I am just finding the magnitude of electric field. Remember that. Direction I will talk later. Direction we can say it is on the right side. So if I take K common outside, it will be Q1 by R1 square plus Q2 by R2 square. Now K value is 9 10 to the power 9. What is the value of Q1? Q1 is 10 to the power minus 8 divided by, what is R1? R1 will be equal to 0.05, 0.05 square plus, what is Q2? Q2 is again 10 to the power minus 8. See, I am not considering minus sign there, because minus is just representing its magnitude. I am just taking its value. Minus just will give me the direction of it. So R2 is 0.05 square. So when I solve this, I will get the value of E net at A. So I am not solving it now. You must solve it by yourself and you will get the answer. That will be the value of E net, that much Newton per coulomb. Finding the electric field at B now. So at B, due to Q1, there will be a repelling force. I am writing it as E1, because positive charge kept at B, this positive will repel. This negative will attract it. Why it will attract? Because I have kept a unit positive test charge, that will be E2. So net positive charge will be E1 minus E2. See, someone may think, why not E2 minus E1? Since E2 is far, the electric field produced by E2 will be less. If you want, you can find the value of E1 and E2 and then decide what to subtract from what. It is up to you. So let me find for point B, let me find the values of E1 and E2 individually first. So what is E1? E1 is K Q1 by R1 square. So what is K? K is 9 10 to the power 9. What is Q1? Q1 is 10 to the power minus 8 magnitude of charge by R1. What is R1? From here to here it is again 0.05 square. Well, this will give you the value of E1. And E2 would be how much? K Q2 by R2 square. And that will be 9 to the power 9. What is the value of Q2? 10 to the power minus 8. If you are still thinking and distance will be 0.1 plus 0.05, 0.15 square. If some of you is still thinking why I am not using negative sign here, see, it is magnitude of even. So I am just taking the magnitude of charge, and magnitude of charge is 10 to the power minus 8 coulomb only, because magnitude of charge cannot be negative. So the net electric field, if you find, you will get that this value is higher and this value is lower. You can find and check. Net will be equal to E1 minus E2. So E net value at this point B will be equal to this value minus this value. At point C, if you see, if you keep a test charge here, this charge will give a repelling force, repelling electric field, I will say E1, and this charge will have a attracting electric field E2. Now here E1 and E2 are in different direction, they are not in the same line of action. So we have to take the vector sum. So E net for the point C would be vector sum of E1 plus E2. Directly I am doing vector. See, in both the previous cases, I just found the magnitude of it. Direction I will write at the end for everything together. So here, since it is having two different things, I will just take the magnitude of that. So magnitude of that will be equal to E net's magnitude will be equal to root over E1 square plus E2 square plus 2 E1 E2 cos. What is the angle between them? This 60 degree, this will be 120 degree. Angle between them is 120 degree. So what is the value of E1? E1 will be equal to K. What is Q1? Q1 is again 10 to the power minus 8 by R. R is 0.1 square. Plus what is E2? It is again K, 10 to the power minus 8 by 0.1 square, and this will be 2 into once again the whole square. Here also the whole square. 2 into the same thing, K into 10 to the power minus 8 by 0.1 square into K into 10 to the power minus 8 by 0.1 square into cos 120 is minus 1 by 2. So when you solve this equation, you will get the value of E net at point C, and that much Newton per coulomb. So after solving everything, you will get the answers as at A, the net electric field is 7.2 10 to the power 4 Newton per coulomb, and C, this is the magnitude, direction is directed towards right side of A. Same way at B, E1 was stronger than E2, so it will be directed towards left, and the value magnitude was 3.2 10 to the power 4 Newton per coulomb, directed towards left of B. At C point, if you have used that vector summation, you would have got the value of E net as 9 10 to the power 3 Newton per coulomb, directed towards right. See, the net thing will be like this. So I can write directed towards right from C, and it is parallel to line joining QC. That's how you are finding the value of electric field at A, B, and C. So in today's class, what we saw, we learned about electric field, and electric field was found to be the force per unit test charge. Then we came to know F is equal to QE from today's lecture. Also we learned about electric field due to a point charge, and we found the value to be K Q by R square. I am talking about its magnitude. And we also found what is the electric field due to system of charges, and that is similar to principle of superposition, where E net will be equal to E1 plus E2 plus E3 plus up to En. And based upon all these topics, we saw 3 or 4 numericals which were taken from the textbooks. Now at this point, once again I am repeating, please open a textbook, whatever you have, NCERT book or state board book, whatever books you have got in your hand, open the book, and from this chapter up to wherever I have taught you, start solving the questions. Only when you solve questions, you will get doubts. When you get doubts, you can clarify that. Fine. So thank you guys.